Hello student, today I am going to explain you people AD lab experiment 1. First lab experiment of our AD lab, that is design an astable multivibrator circuit for 3 cases of duty cycle. Duty cycle equal to 50%, duty cycle greater than 50%, duty cycle less than 50% using 555 timer IC. Simulate the same for any one given any one duty cycle. Either you can consider equal to 50%, less than or greater than 50%. Okay. So for this, we need a Pspice software. How to install the Pspice software? Please see the description of this video. I have mentioned the link how to install the Pspice software video, and also how to design this Astable Multivibrator. The design part of this circuit is also, I have mentioned the link in the description. Please watch that video for design part of this circuit to find out the value of RA and RB. Okay. And I have given the relaxation oscillator experiment video also in the description. So please watch that video for second lab experiment. Now quickly I'll construct this the circuit by using the simulation software, that is Pspice. Okay, then I'll implement this. Here we need 2 resistor RA and RB and 2 capacitor 0.1 microfarad and 0.01 microfarad. We need one VCC to supply 5 volt, and we have to measure the output at pin number 3. And for the capacitor waveform, you have to connect a voltage level marker at pin number 2. Okay, and we have connected one diode parallel to RB. When you connect the diode parallel to RB, the effect of RB will be shunted if you connect the diode. So this everything I have explained in the design part. Now let me quickly construct this circuit diagram, okay, in the simulation software. Just open your simulation software, go to file, take new project. So here you have to select analog or mixed DAD and path, let it be the default path, or if you want to change, if you want to save all your files in your folder, you can create one folder and you can save it. Give the file name. I'll give timer 1, any name you can give here. Click OK. See, this file is already exist. This file name already exists. Do you want to replace it? If you want to replace, click OK, else give some other name. Okay, I'll give some other name, like I'll give KTP1. Click OK. So here it will ask you whether create based upon the existing project or you want to create a new blank project. I'll select this, create a new blank project. Click OK. So this is the area where you have to place all your components and you have to construct the circuit. To get the components, go to place and part. Select part. In the select, there are so many libraries are there in the part. Each library has a number of component. Okay. So whichever component we want, with respect to that component, we have to select the library here. For example, look at our diagram. We want the IC here, 555 timer IC, which is 8-pin IC. We want this IC. So there are a number of libraries are there. So you should know in which library that particular component belongs to. If you don't know, just start from the beginning. Select this ABM. Just type here 555. Okay, you can see preview here if the component available in that library. We are not getting anything. That means this 555 timer is not there in this library. Select the second library, analog. No, it is not there. Analog P, breakout, design cache, eval. Okay, in the eval, just type here 555. See, now we are getting in the eval we have this 555 timer IC. Okay, then select this, place it wherever you want, how many component you want it. For example, if you want 3 components of same type, then click 3 times. Then if you want to end this, right click, end mode. Okay, we got 3 components. If you don't want this, just select it, remove it. Just select it, delete. Okay, you can do zoom out as well, zoom out, zoom in. Okay, so you want, you can do it. Now this is the 555 timer IC, which is of a 8-pin IC. Now what else we want? Just look at our diagram. We want RA, RB, and we want 2 capacitor. Okay, I'll take RA go to place, part, in the analog, just type R, you will get the resistor. Take it, rotate it, we want in this fashion. I'll connect one resistor here, one more I'll connect here. And we want two capacitor, one capacitor is connected below the RB and one is here. Okay, go to place, part, just type C, you're getting the capacitor, rotate it, click one capacitor here and one more capacitor somewhere here. Okay, right click, end mode. Okay, now after the first thing is, see student, you have to place the component. First you have to draw the circuit, based on that you have to place the component, then you have to give the connection. Okay, just see your diagram, there is a connection between pin number 8 and pin number 4. Okay, and there is a connection between pin number 8 and pin number 7. In between this connection there is RA. So that means one end of the resistor is connected to pin number 8, other end of the resistor is connected to pin number 7. Now take this wire, thin wire, there is a connection, zoom out, take this pin, there is a connection between pin number 4 and pin number 8, correct? Okay, and one end of the resistor is connected to pin number 8. See, while connecting, you should be very careful. You have to connect this square box to square box until you find that red dot. Once you find the red dot, you have to stop it. Okay. Then there is a connection between this resistor to this. There is a connection between this resistor to capacitor. Okay. Then we will see a diagram. Pin number 7 is connected to other end of this resistor. Pin number 7, take this wire. Pin number 7 is here connected to this other end of the resistor. Okay, then we will see what else. There is a connection between pin number 6 and pin number 2. Connection between pin number 6 and pin number 2. Okay, I'll take the wire. Pin number 6, drag it. Don't stop here. Just continue and connect to pin number 2. Okay, and you just see the circuit diagram here. There is a connection between pin number 2 is connected to other end of RB. One end of RB is connected to pin number 7 and the other end of RA. And here the other end of RB is connected to pin number 2 or 6. Both are same. Now I'll take the wire. I'll take it from the other end of this RB, sorry, and that is connected to pin number 6. Okay. Now next you see. Next capacitor is connected to ground and from pin number 1 is also connected to ground. Pin number 5 connected to the capacitor 0.01 microfarad. Other end of the capacitor is connected to ground. I'll take the wire. Pin number 5 is here. I'll little drag it. I'll not stop here. I'll continue. I'll stop somewhere here. Then again I'll continue. I'll connect to this capacitor. Okay, now this end I'll drag. I'll connect to this. From pin number 1 also I'll connect to this. Okay, see the circuit diagram here. Pin number 1, pin number 5 and the capacitor other end, all three are shorted here. Okay, and we have to connect the ground. Okay. After doing this, first thing is you have to make the circuit diagram ready, then you have to place the component, then you have to give the connection. After giving the connection, the third point is you have to give the values for your component. For example, this R1 is the name of the resistor, and here this is the value. So what value you have to give, that is depend upon your design, whether you are designing the circuit for 50% duty cycle, less than 50% or greater than 50%. Based on that, you have to calculate the RA and RB value. Those values you have to put here. For example, assume that, okay, let's consider the duty cycle which is greater than 50%. In case of greater than 50%, I have given the values here. See, case 1, duty cycle equal to 50%, my RA value is 7.2 kilo ohm, RB is also 7.2 kilo ohm. Case 2, If my duty cycle is greater than 50%, that is duty cycle. Let's consider the duty cycle for 75%. In case of 75%, T on is equal to 0.75 millisecond, T off is equal to 0.25 millisecond. Okay. In this case, if I put in the substitute the formula, I'll get RA is equal to 10 kilo ohm, RB is equal to 3.6 kilo ohm. This is for duty cycle which is greater than 50%. Okay. I'll consider this second case. The value of RA is 10K, RB is 3.6K. So this is RA, right? So I'll double click on this 1K, the value I'll give as a 10K. And the value of RB is 3.6K. Okay, how did we got this value? It depends upon the design. Now here, the value of capacitor 0.01 microfarad. Oh, sorry, 0.1 microfarad. This is the first capacitor. And the second one is 0.01 microfarad. Okay, values we have given. Now ground you have to connect. Take this ground here, go to source, select the 0, connect here. Okay, and one thing what we have to do is we have to connect the VCC. You see the circuit diagram here. VCC, that is plus 5 volt, we have to connect. Either you can connect to pin number 8 or pin number 4. How to get that source? Go to place, part, in the source, just type VDC. If you type VDC, you will get the source. Positive end, we have to connect it, rotate 2 times, or mirror vertical also you can do it. Connect to pin number 8 and end mode. And what is the value of this? See, this is the name. V1 is the name of this source, and this is the value. Double click on this, give 5 volt. Done. Now here the negative end we have to give the ground. Take this ground. Just click here. The ground we have connected. Okay. Then after giving the connection, just save it. Okay. Now go to Pspice, new simulation profile. Click on new simulation profile. Give any name here. Okay. Then click on create. Once you click on create, in the taskbar you can see one window has opened. Open it. Give the run to time 10 millisecond. You can change this value based on the requirement, based on the waveform how you're getting. 0.01 millisecond. Click apply. Click OK. Okay. Now, if you want to see the output, you have to connect the voltage level marker. These are the voltage level marker. You have to connect one at pin number 3. And if you want to see the capacitor waveform, you have to connect at pin number 2 or pin number 6. Or here you can connect it. So take this voltage level marker, connect one to get the capacitor waveform. Connect here at pin number 3 to get the square waveform. Okay. Right click, end mode. And one thing we have missed here, that is the load resistor. Okay, that we have to connect here between pin number 3 and ground. So first I'll execute this. I'll get an error. Okay, if I don't connect the load resistor, just save it and then execute. See here we are getting an error, simulation aborted, because there are errors during the net listing. For this, what we have to do is we have to connect the load resistor. Okay, just remove this voltage level marker, go to place, select part. In the analog, just type R, take one resistor, rotate it, place it here, take wire, drag and connect to pin number 3, and from here connect to ground. Right click, end mode. The value of this load resistor is 10K. Okay. Now take voltage level marker, connect here, end mode. Save it or run it. Now see, we are not getting error. Now here you can see this window, you can open it. See, this is the exact output that we got here. So here we have designed for duty cycle greater than 50%, and we selected, see, this is T on, this is T on, and this is T off. T on we took as 75%. Correct. Now see here, this is bigger than this T off. That means greater than 50% duty cycle we selected. So that's why we are getting like this. So this is 75% T on, 25% T off, again 75, 25%. And this green color waveform here, you can see, that is sawtooth waveform, that is capacitor waveform. And a student, you can separate this. You can separate this square waveform and this sawtooth waveform by plotting the different windows. So this I have shown in the second experiment, that is relaxation oscillator. In that I have shown how to separate these two waveforms. Okay, and go back to your design. You can change it. You check it out for 50% duty cycle, less than 50% duty cycle. Less than 50% duty cycle, what you have to do, you have to change this value. You have to make it R1 is equal to 3.6 kilo ohm and R2 is equal to 10 kilo ohm. Okay, for duty cycle equal to 50%, you have to make 7.2 kilo ohm, 7.2 kilo ohm. Then the waveform you will get exactly 50%. T on is equal to 50%. T off also you will get a 50%. In case of less than 50% duty cycle, you will get this form, this waveform in the reverse order. T on will be 25, T off will be 75%. I hope you understood. Student, any doubt, in the comment section, you can ask me. Okay. Thanks for watching. Thank you, student.